9702, October, November 21, paper 2, variant 2. The topic includes waves, stationary waves, superposition, those five. The question number 5, a tube initially fully submerged in water. The axis of the tube is kept vertical as the tube is slowly raised out from the water. A as in this figure, this is a tube which raised out from the water, and on the top there we have a loudspeaker, right? A loudspeaker producing sound of 530 Hz is positioned at the top end of the tube as it raised. The water surface inside the tube is always level with the water surface outside the tube. The speed of the sound in the air column is in the tube is 340 meters per second. So these levels are the same. Part A, and the speed of the sound air column in the tube is 340 meters per second. Part A. Describe a simple way that a student without requiring any additional equipment can detect when a stationary wave is formed in the air column as the tube is being raised. So whenever the the waves goes reflect from the water level and come back and superimpose, so it may have a constructive interference or may have a destructive interference. Whenever we have a constructive interference, a louder sound will make, and in case of destructive, a quieter sound will heard. So either quieter or a louder sound can be heard. Part B. Determine the height of the top end of the tube above the surface of the water when a stationary wave is first released in the tube. Assuming that the antinode is formed level with the top of the tube. So antinode on the top and the top on the surface will have initially uh, lambda by 4 wavelength wave. So the length is equal to the lambda by 4 because when the distance between an antinode and node is lambda by 4 in terms of wavelength. So L is equal to the lambda by 4, and lambda is the speed over frequency. We know the speed, we know the frequency. So 340 over 530 into 4 is 0.1603. It is 0.16 meter. Next, determine the distance moved by the tube between the position at which the first and the second stationary waves are formed. So, first sound here to end, the distance is with respect to lambda is with lambda by 4. And the open end will have an antinode and the closed end will have the node. The second possible waveform will be half wave and with the full wave. So this from this point with the node and this node will be the lambda by 2. So the increase will be L equals lambda by 2. So this will be the increased length. So increased length will be L lambda by 2. So lambda is 0.64 to the means 0.32. So the distance increase was 0.32 meter.